this work?
Yeah.
Can we have these lights off? Hello.
Hi.
Yeah, well, I'm not entirely sure how this is gonna work out, because we tried once before to do this kind of overview of this project. Didn't quite work. So we try again. I'm gonna tell you, I think, a little bit about the story behind it, in a way, why we've been into this journey, and then maybe talk you through some of the, I don't know, the technical stuff. Well, he will do that. And yeah, well, this is a journey that started quite a few years ago. Kind of come from different backgrounds, and also originally we were collaborating with a third person called Pedro. And in generally, well, we all done quite different paths, but we all shared a sort of common interest with this idea of relationships between sound and image. And beside this sort of interest, in a way, as a concept, we were really interested also in the same artists and the same processes, in a way. So we started a lot kind of sharing, discussing some of this. And I think Kandinsky has always been a bit at the center of these kind of conversations. Not so much for, let's say, the aesthetic qualities that Kandinsky has, but rather for this idea of merging languages. He's one of the first that developed sort of concept of painting music. The idea of taking something that you cannot really visualize, that is kind of so ephemeral, and paint that. And that's, I think, is something quite fascinating, to merge these two that really become one single language. And in a way, he started also using some kind of terminology to describe both words. For example, he started calling his paintings composition, which, well, essentially it's a musical term. I guess this has always been kind of quite fascinating for us, finding some abstract concept or kind of terminology that could really describe both words, the sound and the image. But also, I think another interesting aspect of Kandinsky, why we like it, why we believe it's so relevant in a way, also what is happening today, is this idea of systems. He wasn't really painting music just by what he was somehow, say, feeling as a kind of, I don't know, epidermic approach, in a way. He was really developing systems. So there were quite precise rules of how he was translating music. Rules that, in a way, they're not really analytical. You cannot really go back to the music from his paintings. And I think also this is something that is pretty interesting. It's a system, but at the same time, it's an incredibly personal one. So it has these primitive symbols and geometry and all these kind of rules of combining this. Also, something that we've been always very interested in is always slightly more analytical representation of sound. There are obviously many ways of visualizing sound or representing sound that somehow are also incredibly accurate. So anyway, we started on one side becoming very interested in waveforms, but also finding kind of relationship between different ways of visualizing sound, different kind of languages. For example, the sort of classic music notation, it's a pretty good system in a way for visualizing sound, for describing sound. It works, pretty well. But at the same time, there's many composers that started questioning these, or started playing with ideas that maybe they could be different systems that maybe they're not as precise, but in certain cases could be more expressive. And so this idea of kind of graphic scores and so on. So I think this was a bit the ground for the project that we started developing, we really didn't want to make, say, visualization of a specific piece of music. We really wanted to build an instrument, or say, develop a language. So inspired by, I think, this kind of structure, this idea of a sort of horizontal stream of images, we came up with this idea of this system called partitura. Again, this was a collaboration at the time between Nathan and Pedro, which they were working together, and myself. And we developed this kind of first tool. I'm going to show you some images. They look a bit pixelated, but they're not in reality. And in a way, the idea was to develop a system that, on one side, it is simple enough to be something quite coherent, quite pure, a little bit similar to those systems that I showed you, but at the same time, flexible enough to be able to describe many different kind of scenarios. So we really started this idea of this kind of horizontal structure, and in a way something that we thought at least we would never leave. It was a kind of core of this, and develop these systems that essentially involves different kind of modules that do different things. They interact with each other, and they can be controlled in many different ways. Also with sound, let's say. So here there were just some screenshots from of different modules, different combination from the very first things. This probably was, I don't know, 2010 maybe, or something like that. So it was quite a while ago, but I think it's good to kind of see, I don't know, how this evolved, and in a way also by this kind of, in a way, very simple rig, essentially a horizontal line. How many things, how many kind of variations have been developed. So yeah, just gonna go forward without talking much, but at least you can grasp a bit of an idea. And hold on. So this kind of lasted, I mean, for a few years. We slightly underestimated, I think, the amount of work to get something like this going. But we'll talk about it in a minute, I guess. From this sort of rig, this kind of horizontal structure with sort of graphics core, if we say, we started developing a new system where this could be expanded and not necessarily work on this sort of fixed rig, let's say, but actually have many different kind of rigs and sort of break this thing. So this is where the system sort of went and then changed name and so on, and we kind of started all over again a few times. And essentially the purpose of this system, it's to collaborate, I guess, with musicians to create this kind of interactions and to do these other visual concerts. So we've done a few of these collaborations. This one was the latest, or one of the latest, I guess, with the pianist called Vanessa Wagner. So that's the concert that Nathan will be performing, well, without me, without the pianist. So it's kind of a slight simpler variation of it. Maybe we could start showing you some stuff. It might make sense. But I'm going to show you a sort of excerpt of some of the stuff that we've developed with the software before we get into showing the actual tool. Let me start with this.
Sorry, can you switch off the light here?
project that in a way we didn't start say this whole system, this whole collaboration with a specific output in mind. It was almost if it was a kind of continuous research. In fact, in the end, we haven't made that much work with it. That's a bit crazy, but it's more this kind of constant research through which, in the end, we actually learned quite a lot. And something that came through is quite interesting. Is in the beginning, these systems were incredibly precise, direct in the sense with the sound, and the more and more we started creating things that where the interactions are a bit loose in a way. So in a way, also the kind of language and everything it developed and changed quite a lot throughout. So here it's another clip from a live concert. This is not how it's gonna look on Saturday though. We've always been like really fascinated by let's say the act of making music. There is something about making music that it's really immediate in a way. This kind of fact of, let's say, producing sound in real time, and probably because it's a bit less, I guess, technically complex than generating images, or I don't know exactly why, but you know, tools have developed in a way that you can really improvise and do stuff in a certain way that is very different than producing images, animations. That generally it's always a crazy bottleneck. Either if you do them in real time, if you code them, or if you use existing software in a way or another, you always have this problem of I don't know, tediousness, and it cannot really be compared with like playing a synthesizer, or in a way composing music. And really wanted to use something that we could actually in a way compose these images and interact with them in a very intuitive and quite fast way. So in order to do this, we developed this system. So all the images that you've seen are part of this kind of unique very big parametric system that basically just expose parameters. So we don't really go anywhere near or almost into the patches, but generally we develop this kind of sublayer, this interface, which is unfortunately, I cannot really show you, it's on the iPad, we're going to show you a video. And through this we can basically control this whole thing. So it kind of really gets close to, I don't know, the idea of a tool, of an instrument in a way. So our idea was to have these different modules that they can do a lot of different things, and all this kind of bunch of parameters exposed. But then, in a way, you have this problem that each one of these parameters you want to be able to control in many different ways, with different types of automations, or maybe with audio, and you want to be able to map these. And because we have hundreds and hundreds, I don't know how many hundreds of parameters we have, yeah, like thousands, and in a way, it's kind of a tricky thing to do. So we came up with this idea of this automation system, a kind of engine that can generate different types of automation, and then kind of dispatch them to whatever single parameter or spread of parameters. Maybe you can show the video. Actually, let's. No, can we have the audio off? One second. I'm gonna just switch. No. Tanto lo devi mettere. So that's well, that's a really shitty video that can pretty much show you what the interface does. So you see this kind of pink line, that's our single value, and then in here, for example, generating some LFOs. I mean, as you go forward, I think there are, I don't know, different things. This noise and this. Also, the last part you can see here we are. Yeah, we're basically mapping sort of audio input. So there is, in a way, quite a complex system to essentially be able to animate, do stuff with these parameters.
And then combine them into this mixer interface.
Yeah, and it's not really in this video. In this video only shows like how you can control single values, or we have the same thing for spreads of values. So in this interface we have, I don't know, this again, hundreds of these parameters, and then for each one you can just basically select and then control whatever automations you have. So this, I think, was a bit the core, in a way, of the system, because it's what kind of allows to really separate in the end the parameters and how you really animate them. So this is on one side, and on the other there is all the kind of audio analysis aspect, which is it's a universe of its own. And this we collaborated with a very good sound guy, and we developed like an FD, a VSD plugin. So basically this VSD plugin can be loaded into any audio sequencer or anything, and then it sends data via OSC. And then with this automation engine, we can just read all the different analyzers that we have and map them the way we want. So that's a sort of general kind of base. Maybe we're gonna show you some stuff now in like, I guess real time from the system to maybe show you some different modules. But I think we should keep this second part a little bit more interactive. So yeah, so we
can pass by also.
To that. Yeah, actually, that's. But anyway, maybe. Oh, first of all, you should probably explain this much better than me. But if you have any questions or any kind of random thoughts as we go forward, just shout, and I think we can make this a bit more into conversation. But anyway, let's start. So, system. It's kind of what we liked. It's some kind of complexity where this module can interact together, and when things can depend from one another. I think that's when you start getting very interesting, complex simulations and complex animations. We have this, say, concept of rigs, like in a way when, you know, character animation, you have a skeleton essentially, in a similar sense, we have different type of rigs and then different type of elements that attach to these rigs and then additional elements or simulations and so on, and you can combine all these different things to create what you saw essentially. So this is a sort of initial rig that we've developed, essentially just a line, a central sort of spine. At the moment, what you're seeing, it's a sort of a kind of LFO that controls the angle of these control points, and then we are having a sort of even kind of radius. So there is a certain amount of control points, and then these ones are given a radius and then an angle. So with the automation system that we have before, here we go. You see this kind of little LFO here that just essentially controlling the angle of this, and this is mapped on this onto this these points. And let's just save a bunch of presets. So here, the same thing, but it's actually controlled via some noise rather than an LFO. And then you see that there are two lines, one that is actually simulated. So in a way that on top of that, there is this additional
spring simulation.
Yeah. And yeah, I guess I don't know if you wanna how technical this should go. If you wanna go and explain, because also this like spring simulation has been like a fucking nightmare. It's not like, that there is a whole universe behind that, all made in complete shader. Like I don't know, 5 years ago, or whenever it was. So there was some interesting stories, I think, in there.
Maybe we can give a overview.
Yeah, let's go forward. So here you see then one of these just kind of rendered essentially. I mean, what you saw before, they're just control points, and then we have different modules. The splines module is kind of tubes essentially where you generate the geometry and you can draw different things. So this is just, well, spring. A spring simulation. And then we have, we can't really see anything. Can we turn off these lights? They don't need to, I think, see us. Still, we can't quite see much. But,
Close the door. Yeah, people, don't be scared. It's gonna be okay.
yeah, anyway, maybe a little bit better. Make this flat. Yeah. Didn't make a massive difference. Okay, well, anyway, on top of this, I mean, I'm just gonna make some example. It might not look really interesting, these things. It's just to kind of give you a bit the principle of how this stuff works. So around this central spine, which kind of can move in many different ways, we can create a system of ribs. We call them ribs. I mean, essentially, like, you know, a series of frames that run along this. They can have different, well, yeah, different shapes, and they can rotate and do different stuff here. For example, show this. Now these are like, I think, triangular ribs. Choose the one after. One after. Yeah, so you can see a bit better. So here are, yeah, these ribs in the kind of shape of a triangle with, I don't know how many splines then rendered in between these. So again, whatever complex animation we do with this central line, then everything else depends on this, in a way. And all you see here, all the animation that you see, it's exclusively generated by that automation system. So in this case, there is X amount of control points, and just, you know, with some noise or LFOs, these ribs rotates essentially. So it's kind of interesting if you, I don't know, start detaching I mean, what you have, let's say, that you're generating and now you are animating, you know. So the idea of this automation system is this kind of abstract concept that can just pretty much, yeah, create, animate these data sets. So yeah, here, well, just some
spring simulations on top.
very interesting. Here we see how these tubes essentially can be drawn in many different ways, and so yeah, in this case we just have a few instances for each control spline, and these are shorter and they, you know, move around with some other parameters, inertia, some other kind of simulations. So yeah, kind of you get an idea about this, what this could do. This is a different rig, so it's not really based on this kind of central line, but rather, well, there are two different rigs. There's this point rig, essentially like a simple particle system that can do, I don't know, quite a lot of stuff, I guess. And then from this we generate these traces. So the points plus these traces, and this become another sort of starting skeleton. In this case, is drawing the same spline. Maybe you go next one. This shouldn't happen, but it's all right. We're actually showing you something that is quite it's a bit old, but so. Here again, there are just, I don't know, a few of these points with additional instances and so on. So yeah, maybe just move around.
Oh, mate. Very good.
So again, while the other rig of this kind of horizontal line is something that didn't really allow us to move the camera around, well, because it was just chopped on the side. I mean, now we start developing things that not necessarily need to. Oh, it's so dark. Yeah, again, just a tiny bit of variation into some steering velocity of these points, and again, you have quite different kind of landscape. This one is amount of point rigs and so on. Maybe. Yeah.
Like in the past.
Touch and break it, don't go. But so exactly in the same way as we were moving those control points to rotate that spine that was there. In exactly the same way, with the same automation, we are controlling how many particles are emitted, or the position of these emitters and so on. So really the principle of how things move, or how they are controlled in a way, it's always the same. So again, here we have these points that are moving, controlled by this like Mel scale analysis, and then there are these traces, and then on top of the traces there are a bit of spring simulation that it's kind of it's tighter towards the points and kind of looser. So you can see these lines that slowly fade and so on. And again, yeah, it's still based with exactly the same principle of these spreads that you can control and map stuff. Then whatever result of this combination of points, traces and splines, that sort of surface becomes a target for this particle system. So there is, I don't know, a few kind of forces and so on, and then we essentially get control of all this stuff. So you see already you can create something. In a way it's quite complex because it's like a chain on things, one on top of the other. Well, it doesn't look quite right now, but I think you get the idea. I think maybe we should.
You good?
We have a bit of volume. So here, well, the rig here is very simple. It's just a plane and there's a bunch of particles. But I guess we're using different type of noises controlled by the audio to apply forces and basically detach them from their target. So actually the audio kind of sculpt this sort of landscape bit by bit. But I think you need to go up the it's another example of this kind of stuff getting a bit looser in a way with the, I don't know, interactivity of the sound and so on. Sometimes there are a lot of simulations in between and things get a bit more delicate, or at least this is a bit of a direction where we've been going. Interactive with you guys, because I don't know if you're getting bored.
Logic with the camera control now?
Sorry?
Is there some kind of logic with the camera control?
I was driving the camera.
Okay.
In the morning. So.
But no, well, it depends. We have two kind of cameras. One which is an orbit camera, not the one. It's another orbit camera that another developed, and then we have a fly-through camera. So also we kind of didn't really mention that there is all like a presets saving sort of system. So anyone, we can save, the whole scene, or we can save any given module that then we can combine with other presets of other modules and so on. So the camera can be, the fly-through camera is just for real time, but the actual orbit camera is a series of parameters that you can, you can automate like the rest, I guess. So, but we use it live a lot, though, the camera. I think it's so you can always hide, things that break. And I think maybe it could be nice also this thing of the specifications. Maybe this is something we could show. So each each module basically has a kind of list of parameters, and each parameter has a series of kind of specifications. So it says, yeah, you can see the pin size, or if this is something that can be blended between one preset and the other or not, or I don't know what kind of what is it? Yes.
Yeah.
And the OSC tag and so on.
And then when we save presets, we just select those parameters which are different from the main value, the default value, and then store the wanted value plus all the automation information to rebuild the animations for that parameter.
Like the very sophisticated remote, is that done from scratch or is it built on some framework? Or I mean, is it using Lemur? Or?
Lemur, yeah.
Okay, cool.
It's been actually very painful because in the end, yeah, we used Lemur, but we quite quickly got also into some limitations of it, and because we have so many parameters that basically we finished the limit of memory of stuff that you can load into Lemur. So basically we have to also open different projects, so it gets, so we actually have now also several iPads that sometimes we use. But we have one version of the interface which is everything. So it's also quite long and tedious to go through because there are, I don't know how many pages, but many. And then there are some kind of micro interfaces that we develop just for the live. Sometimes also with physical interfaces, maybe it's better to use live.
Sorry, you mentioned about you build your own DSD and stuff, but to do what? Sorry, I'm just a bit confused because to do the audio analysis or general?
Yeah, the audio analysis is done completely separate from VVV.
Wow.
So the audio analysis is done in a custom plugin. Originally we've done something in Max and then in Max for Live, but in the end we thought that the best way would be to have a VST, so you can just plug it into any software and it's like a standard. So then the sound analysis, like it's a universe of its own. There's so many different things. So.
But sorry, how do you get the data back into V4 then? Through the audio engine and the VST or?
OSC.
OSC.
I see, yeah.
So you store your data also in the OSC?
You mean the presets?
Yeah.
No. We just send, because the system works on two different machines. We have a manager where I load presets, and basically this manager talks with the iPad. So here, it's the manager and manage all the parameters. And then this manager sends to the render machine. In fact, during the live shows, we usually have different machines. There is a backup machines that runs.
There are many things that can crash, basically. So before you figure out, the last show we did, it was like a big auditorium, like 1,100 people, all really quiet, proper classical music, seriousness. Maybe this thing like crashed in the middle, but also the hot backup crashed basically like in the middle. It was like black for quite a bit. So it's a bit sketchy in a way, the whole thing sometimes.
Anyway, the presets are just saved here as XML files.
But how do you store the you have to go through the budget to collect the field information.
Basically,
How do you collect your parameters?
How do you collect?
basically, for each module, visual module, like let's say splines, we have a specification file, like the one we showed you, and each module has those parameters, and the manager on startup load all the specification for all the modules and build a unique big spread, a buffer, which contains all the parameters of the system. Okay, and so it applies all the animation, all the automation in that buffer, and then the changing parameters of this buffer are sent to the renderer. Okay, so everything happens here.
So with the remote, you basically remote the
remotely,
manager, which remotes the render.
Yeah, this is the manager.
Yeah,
So
okay, the manager. Yeah.
I just change values here that these values are written in the buffer. Okay, and this after sent to the renderer. So this is the brain where everything comes. So also the analysis, for example, is routed into the buffer and then sent to the manager, to the renderer.
I think all this, in a way, crazy complicated thing, it's just to kind of facilitate a really immediate use of this. And in a way, we realize that to really discover stuff and in a way to design things and to not slow down the design process, if you're actually very fast in saving presets, iterations, recalling them, remodifying them, and so on, actually you can really develop things which you could do also if this whole crazy system wasn't there, but it just would be so slow and would be so confusing that would really stop this, I think, creative process.
Were you playing some with like multiple controllers, and did that affect how you were designing your data flow?
You mean multiple iPads? Basically, no. Till now, we just implemented one iPad with everything. Plus, during the live show, we have also another iPad.
Yeah, we work with two iPads and sometimes with some physical interfaces.
Just for macros, for example.
I mean, in a way, you can use anything that just sends OSC. I mean, each parameter has an OSC address. You can use anything to just send. And then in this case, also from the manager, the data goes back to this. So at least we have the updated and we have the
preview of what's happening.
Yeah, that's a,
the connection, I didn't get something. The connection between the render and your computer right now, it's a buffer, but it's OSC or it's by grouping. I didn't get that.
Basically, here there's the buffer containing all the parameters, and then I send as raw data.
But sorry, when you mean you send, how do you send it? What do you
UDP. Just raw UDP.
So through Ethernet, cross Ethernet cable.
Yeah, we have a router here.
Yeah.
So all the computers are connected into a network.
Yeah.
And also the iPad, and everything runs through this network. So yeah, all the control interface talks via OSC, and then to optimize data, we just send via raw data to the renderer.
maybe you can show some of those like crazy 200 pins shapes.
Sorry, how do you optimize? Like, don't you get latency and stuff like that? Or did you? No, you don't.
I mean,
I fucking do.
Obviously doing
yeah,
it
there's always some delay that I try to optimize. Like for example, I don't send the old buffer. I just send the changing parameters, for example, and then on the render machine I have the same buffer. So I send the changing values with the index of the changing values. So I rebuild the buffer.
You only change the things you
just
need to change.
because there are
Have you seen like
3,000,
Ghost in the
4,000.
Shell, you know, this like living thing that we honestly also are not completely in control of what is that.
Yeah.
I'm a bit
Makes it
worried.
sound is in control, but he actually also not quite completely, you know.
My attackers in a minute, yeah?
Yeah,
That's what
here,
people
for
are
example,
reading,
I'm
that's
receiving from the manager. Yeah, I'm receiving all data that are driving. That, in fact, if I stop the network, or if I stop the automation, the animation of the spine. So this is receiving, and it's really a set slice into this buffer. It's 4,000 values. Yeah. So after that, I send this buffer to all the modules. I need to remember it's 2.5 years batch. Let's go to read. yeah, there's this receiver with all the values, and on Open I just search for these parameters with these OSC tags, and I provide them to the module. Okay. So all the shader receive. Here there is the spring simulation. Actually, it's my first complex shading. And so each module will receive, will get data, sensible data from the buffer, and we'll use it. It's really the same. Get data from the buffer, unzip, and provide data to the shaders.
I'm trying to use exposure.
Yeah, but if you have thousands of parameters exposed.
It's actually, yeah, I'm not sure about the stability, but it's actually pretty good. Since you don't need to unzip these, you basically do your IO box as an address.
Yeah, I know, but depends if you have also spreads and all this kind. It's not that flexible.
We're running over time. Maybe we just, because I think there's some other workshops now that are starting. Yeah, but I don't know if there's any that.
Okay. I have a question. Like, how many particles are used for Ravel Landscapes or exproximate?
How many?
Depends from the scene.
Yeah.
In a way, how they're rendered. You know, some scenes, I don't know, use 1 million, I guess, and some other scene use, I don't know, 10,000.
Ouch.
I want to see, please.
Oh! They're playing Jenga, mate. Don't worry about it.
I mean, each scene, there's a bit of difference between, let's say, like a music visualizer and these. In a way, if you take one of these scenes and feed any type of music, it's not really gonna work. You know, it's stuff that is so fine-tuned, so calibrated that it's almost like a traditional animation somehow. In a way, things. Also with the audio analysis, in a way. I mean, you map and calibrate stuff to work specifically with a certain kind of, I don't know, piece of music. So I think in the same way there is a certain scene. If you obviously turn everything on, it will explode. I don't know exactly what. So you have stuff that is on, stuff that is off, and so in this one, there's also different type of shading. Like, so sometimes they're just like sprites, and we have loads of them. Here are, you can't quite see, maybe we should zoom in a bit. Yeah, you see here, for example, there are some kind of flying tetrahedrons and stuff. So it depends also what you're, or you're rendering, how many lights. We have a rig that we can have like 4 lights with soft shadows and stuff, but if you turn all of them on, then sometimes it gets slow. Also the color. I mean, actually, there's quite a lot of stuff we didn't talk about that is quite interesting, but it's also the color, how we actually map the colors, but maybe another time.
We'll stay here as long as you want to talk about it.
Should wrap up, I think. So I don't know. Thanks, I guess.